Sir. All right. Tomorrow. I'm here Monday.
All right. Welcome to Former Chem Solution, and we are here to unveil and unravel some of secrets in science. So let's get this started. So we're going to be talking about density. Density. Well, what is density? Density is the mass per unit volume of a material. So density is the mass per unit volume of material. So it means that for every substance have a particular mass. They have a particular mass for one particular volume, maybe in meter cube, centimeter cube. So let us look at the formula. So density, which is actually represented with this symbol rho, is actually mass per volume. So, in other words, how do we apply this formula? Now, for example, we do know that anything that is denser than water or denser than any fluid can be gas, it can be liquid. So, but we're going to be looking at water. Anything that is denser than water cannot float. And anything that is, water is more dense or that is less denser than water, we float. For example, we know that icebergs float on water. You know why? Because they are less denser than water. That's why they float. And we also know that metals, and some other materials like stone, glass, they cannot actually float in water. When you throw them inside the water, they sink immediately. But we do know also that we have some machines, some things, technology that we have developed for ourselves. For example, the ship. The ship is made of metals. How come it floats? So let us look at how density can actually help us to understand the reason why materials that are more denser than water can actually float. Now, for example, it means for us to make anything float, we have to have a way of actually reducing the density. So now, you have to understand that this formula called density, let's look at English, the shorter symbol, V, says that density is actually directly proportional to what? To mass. It means that the more the mass of an object, if the volume is kept constant, the density will increase. While, we also know that the density of an object is inversely proportional to what? To the volume. So now, it actually means if volume should increase, density will reduce. If volume should reduce, density will increase. So you see, so now, this will bring us to this. This is glass. The density of the density of glass is actually 2,600 kilogram per meter cube. The density of iron, is actually 7,900 kilogram per meter cube. And the density of water, you can see, is 1,000 kilogram per meter cube. You can see these numbers here, that glass and iron, they are more denser than water. So now it means that this glass should sink. For example, see it right here. If I should drop it like this and release it, it will sink to the bottom. But there's another way I could actually drop it like this, and it will start floating. What is the reason behind it? This is just it. From this particular explanation, when I told you, when the volume increases, density will reduce. Do you understand? So now, how do they do it? Let me draw a little diagram here. This is water. If I draw a metal, a tube, iron, that has this shape, naturally it is going to actually sink. It is going to sink. But if I have a way of beating this iron, this same mass of iron, beating it and giving it a shape that's like this, it will sink to some extent, then it will come up a little bit. Now you can see that the volume of this metal has increased. The volume of this metal that was once like this, I have actually increased it by beating it into this shape. It has actually gotten a volume. The volume, all the materials are no longer compact together in one small size. Now I have increased the volume. So what is making it to sink? So long you drop something, any material on water or any liquid, there is a force called Upthrust that acts on it, that pushes it up, that pushes it against the weight. The weight is W, and this one is Upthrust, U, pushes up. So it means that the force that is pushing it up is now equals to the force at the weight of the material. That is the force that is pushing it down. Do you understand? So now how do we achieve an upthrust that is equal to the weight? By actually increasing the volume of this particular material, iron. By increasing the volume, we actually reduce the density. Do you get it? So what is upthrust? Upthrust is actually, any force that acts on an object that is placed on any fluid, or whether it is partially immersed or totally immersed. So that one will lead us to the law of flotation. What causes objects to float? An object will float only if the upthrust is equal to the weight of that object. And for you to increase the upthrust, like this metal that is here, when it was just like this, if you had measured the mass of this, the weight of this thing, this mass, measured it here, the weight here, and in the air, it will give you, let's say, 50 Newton. But when you put it and tie a rope to it, this same object that is 50 Newton, and you try to measure it, maybe you tie it to a spring balance, a spring balance that is going to measure it, you tie it to somewhere. This same mass, which is actually 50 Newton, will no longer be 50 Newton again, because a force going up will reduce the weight. So it means that if it's 50 Newton in the air, and an upthrust, a force, let's say for example, 10 Newton acted on it, the weight of this thing will now be what? 40 Newton. But there's a way we can actually increase this upthrust so that it will be equal to 50 for it to actually float. And that is by reducing the density, by increasing the volume of this thing, beating it into a shape, that will make it to actually, become less dense than what? Than the water. So now, this upthrust, according to the law of Archimedes' principle actually stated that when an object is partially or wholly immersed, in a fluid, that the upthrust on that object is actually equal to the weight of the liquid that is displaced. So it means I could actually come here and do something like this. You have Eureka here. Eureka. So this is a liquid. And we carry this object and put it here. So how do we know the upthrust? We can only know the upthrust because now since the water is this full, so anything we put that will accommodate any volume here, it will make water to flow from this place. Because the water will rise, so it will flow through this place. And we can actually put a container under here, where we can actually get the fluid. So if you measure the weight of this fluid, using your mass measuring instrument, we can actually get the force that is actually pushing this thing up. making it to be equal to the weight of this object. So with this little video, I hope you understand how objects float, ships float, even though the materials used in making the ship, the submarines, even though they are heavier or more dense or denser than water, yet they still float. The only truth they actually did is by increasing the volume. That's why you see, under a ship, something like a big balloon is under. If you swim in a swimming pool, and you can't swim, just get a ball with increase that is pumped. When you carry it and hold it, you find that the ball is actually pushing up. Why? Because there is an upthrust that is actually pushing the ball, which you are actually holding. So this is why things that are denser than water or any liquid actually float on the liquid. Thank you so much. I hope you enjoyed full market solution. God bless you. See you again.